Okay, 2.7, combining functions. Last time, I think I start talking about how we can do some of two functions. I give you like two functions with their credit with their domains, and I said how we can do the sum between these two functions, and also we solve some examples for sum of between two functions, and we found also the domain of the of the sum function. Also, I spoke about the difference between two functions, and also the product and the quotient, and also I mentioned the domain of these functions. Then I move to composition functions of circle G of x. We finished 2.7. I mean, today we're going over, sorry for that. We're going over, I think we start talking about 2.82. So here 2.8, one-to-one and inverse function, one-to-one and one-to-one functions and their inverse. So in this section, I spoke about this section last time is one-to-one function. I said the one-to-one function is the function, the one-to-one function is a function such that every element on the domain takes a different element on the range. Also, I give some examples how for like I give you two diagrams, and I ask which function is satisfied to be one-to-one and which one is not satisfied to be one-to-one. And also I give you like the two-way how you can check the function is one-to-one or not one-to-one. So the first way is by using the definition. The definition said if f of x1 equal f of x2, then I have to show or to prove x1 equal x2. I mean, like I have to show the input are equal. If the images are equal, f of x1 equal f of x2, then I have to show that the input x1 and x2 are equal. Then I give you the second way to check the function is one-to-one by using the horizontal line test, such that this line passing the curve or intersect the curve at only one point. If the horizontal line intersect the curve at only one point, we said the graph of the function is one-to-one and the function is one-to-one. Today we're going over the inverse of the function. So this is a new thing here, the inverse of a function. So the inverse of the function is depending on the one-to-one function. So the function must be one-to-one to find the inverse of the function. So I can define here the inverse of the function. So the function must be one-to-one to find the inverse of it. So suppose I have a function, let f be a function, be a one-to-one function, sorry for that, one-to-one function. If f is one-to-one function, so I can write it as one-to-one, or I can write it as like this, one-to-one function. So I have function is one-to-one is f. Now I can define the inverse, the inverse is defined as, so the function will be defined as if y here, suppose that y, if I have y equal f of x, then I can take the inverse for both sides. I can take the f inverse for both sides. I'm going to get f inverse of y equal f inverse of f of x, and the f inverse with the f, they cancel out, so I'm going to get x. Again, the function must be one-to-one to find the inverse of the function. See this one here is very important. The function must be one-to-one. So one-to-one is very important condition. Okay. Now, like I said, y equal f of x, then I take the inverse for both sides. I will get f inverse of y equal f inverse of f of x. So the f with the f inverse, they cancel out. I will get x. The important things I should to know here, the domain of the function f is the same as the range of the f inverse. So this is equal the range of the function of f inverse. So the domain of the function f is the range of the f inverse, and I should to know the range of the function f is the same as the domain of the function f inverse. So if the question asks me, find the domain of the function f inverse, you should to find the range of the function f. If the question asks you, find the range of f inverse, you should to find the domain of the function f. Okay. So depending in the question, if the question asks you, find the domain of the f inverse, you should to find the range of the original function f. And again, if the question asks you what's the range of f inverse, you should to find the domain of the original f. So let me give you a simple example, an easy one. So suppose example, let I have one-to-one function such that the function is f of 1 equal, suppose f of 1 equal 5, comma, f of 3 equal 7, and f of 10, f of 8 equal 10. This is my function. F of 1 equal 5, f of 3 equal 7, and f of 8 equal 10. My question is find f inverse, find here, find f inverse of 5 and f inverse of 7 and f inverse of 10. Here, f inverse of 10. Okay, who will do the first one? Who will find the f inverse of 5? So by using, I will give you a hint how we can solve something like this. So I'm going to use this property, y equal f of x. Then if I take the inverse for both sides, f of inverse of y equal x. So in this example, the first one, my y is 5. This is my y. And this is f of x. Okay? This is my f of x. This is my y. If I take the inverse for both sides, I will get f inverse of 5 equal 1. So f inverse of 5 will equal 1. So finding f inverse of 5, so the f inverse of 5 is 1. So the answer here is 1. It's the input of the original function. It is the input of the f function. The f inverse of 5 is the input of the f function. Okay, now for f inverse of 7, what is the answer?
3.
Is it 3? Exactly. So if, as we're looking here, f of 3 equals 7, so f inverse of 7 will give me 3. Same things here. What is f inverse of 10?
8.
8, exactly. The same idea. The f of 8 equal 10. So f inverse of 10, they give me the input of the original function or is f. So it's the input of the f function. So here f of 8 equal 10. So f inverse of 10 give me 8. Same idea. My y is 10. My f of x is f of 8. Then I take the inverse for both sides. So I will get 8 equal f inverse of 10. Okay, any question for this example? No question. Okay, let's give another example. So this is direct. This is just to show you how we can use this property. How we can use this property. So the example here explain how we can use this property. Now, suppose I have a function, a graph of function. So the second example, find the inverse for the following. Suppose I have a graph of function look like this. I'm going to graph it. This is my graph. Okay. Okay. So the function it's look like this. 1, 2, 3. This is 1 here. Here is 2. Here is 3. Here is 25. And here is it's 30. And here is 35. So the graph look like this. Okay, exactly, good. So the question is find f inverse of 35, f inverse of 30, and also f inverse of 25. Okay, who will do the first one? If you cannot do the first one, I'm going to give you a hint. Yeah, Sandra said the first one is equal 30. This is correct. So I'm going to explain how she thinking. So first of all, we have to graph like a horizontal line at 35. because actually they give you f inverse of the y value, f inverse of the y value. So here inside the parentheses, it must be the y value. So you're going to the y value, the y axis like this. This is my y value. This is my y axis here. You're looking for the 35. This is my 35. Then you have to graph a horizontal line, and you should to see where is this line intersect the curve, the red curve. So you should to graph a horizontal line like this, and where is this line intersect the red curve? Okay, the line here intersect the curve at this point, actually at this point here, and this point has x value equal. If you're looking for the x value at this point, the x value it's look like 3. So the x value here is look like the number 3. So the value here, find f inverse of 35 is 3. So the first answer is 3. Now let's go to the 25. What is the value of f inverse of 25? So inside the parentheses is the y value. Why? Because f inverse, the function is f inverse. So what's the y? So inside is the y value. So looking for the x value. So the same, Christine said 1. This is correct too. So if you graph like a horizontal line at 25, here is 25, and you see what is the intersection between the curve. It's intersecting the curve at this point. So we have to see what is the value for x. So the value of x, it's look like 1. So the value here is 1. Okay, who will do the f inverse of 30? F inverse of 30. F inverse of 30 is the same, like exactly 2. Yes, yes. So the same idea, you have to graph a horizontal line at 30 because inside the parentheses, it's the y value. So you're looking for, you have to graph a horizontal line like this. You see where is the intersection between with the curve, with the red curve. So the intersection intersect at this point. Then you have to find the x value. The x value, it's look like 2. Yes, it's look like 2. So here is the value. It's look like 2. So this value here is 2. Then so the answer, it should be 2. So the answer is 2. Any question for this example? I think this is a web assigned question. So in the exam, if I give you a question like this, it is easy and direct. This is the y value inside the parentheses. You have to pick the x value, whereas the intersection between the horizontal line and the curve. Then you have to find the x value. Okay, now cancellation property. Cancellation property. So the cancellation property is very important property. We're going to use it to find the inverse function, or to check if I give you like 2 functions. Here, Sandra. So I mean, like, the cancellation property is very important property. By this property, I can find the inverse function. Also, by this property, I can also check between, if I give you like 2 functions, to check if they are inverse to each other. This is the goal for this property. If I give you 2 functions, you have to check if they are inverse to each other. So here, suppose let f be a function here. Let f be a function, be a one-to-one function actually. Let f be a one-to-one function, and let f inverse, and let f inverse be the inverse function. Here I prefer I don't like to use f. I'm going to use suppose g. Suppose g is the inverse function. Again, I have f and also I have g. So f be a function, be to one-to-one function. It's not any function. It must be one-to-one function. And g be the inverse function of the function f, I mean, of f. Then I have, then you should to know f, because f is one-to-one function and g is the inverse of this function. So there is a relationship between these two functions. So f circle g of x must, this is actually equal f of g of x, this is equal x. So after you check f circle g of x, they will give me x, and in the same time g circle f of x, this is equal g circle, I mean g of f of x, and this is equal again x. If in the both first one and in the second one, both of them they give me x, this is mean the function f and g, they are inverse to each other. Okay, now I'm going to give you example. The question is, or the example is, example, show that f of x, if I give you the f of x equal x cubed and g of x equal x to the power 1 over 3 are inverse of each other. My question is, check, like that my question, show that they are inverse to each other. If I give you the first function f of x equal x square, I mean x cubed, this is x cubed here, and here g of x equal x to the power 1 over 3. So here x to the power 1 over 3. My question is, check they are inverse to each other. Any idea how we can start? Like anyone has any idea how we can starting to check they are inverse to each other?
You can
Or
plug.
yes,
You
go ahead.
can plug in each other in the original equations that you have.
Like this one?
Yeah.
Okay, perfect, nice. So I'm going to using this thing to check if f circle g they give me x and g circle f they give me x. This is mean the both of this function, the both of these functions are inverse to each other. So let me starting by the first one. Can you go ahead, Aziza, and do it? F circle g.
So it would be x to the 1/3
Hold on, I'm going to write
parentheses
the formula f of g of x, and this is equal what? F of what?
parentheses
Yes.
it's f of x to the 3rd power.
Okay, nice. Then you plug this one inside which function?
You plug it inside of x to the 3rd power, yeah.
Nice. X 1 over 3, everything to the power 3.
And
What
then
is
it would
that
give
equal?
you x to the first power, which is just x.
Exactly. This is like actually 3 times 1 over 3, 3 over 3, and this is equal x to the power 1, and the same is equal x. So f circle g, they give me x. Now let's check g circle f. Again, this is equal g of f of x. Who will do it? Who will do this one? Second one.
You'll plug in f of x into f of x, so x to the third power, g of x to the third power.
Yes, exactly. Then apply the x to the power 3 to which function? To g function, right?
Yeah,
Okay, what I'm going to get here? x3 to the power what?
1 over 2.
1 over 3. Now we multiply the exponent together. What I get?
Yeah, x,
Get x. 3 over what?
3.
3. Because 3 times 1 over 3 is actually 3 times 1. And here actually is over 1 hidden. Is over 3 over 3. And this is equal 1. You should to know this. Okay, now here I'm going to get what? X
X
to the
to the
power 1.
1,
And this is equal what?
x.
X. Thank you. So F circle G, they give me X. And G circle F, they give me X. And this is mean in both of them, this is mean that both of the function are both of them are inverse to each other. Because after I check that, F circle G and G circle F, both of them, they give me the identity X and X. This means that both of the function are inverse to each other. So here I can said F and G are inverse to each other. F and G inverse to each other. Okay. Any question? Okay, so we should to know the important thing here, symbols. F inverse of X is not is not 1 over f of x. This is not 1 over f of x. But f inverse f of x, everything to the power 1 over minus is 1 over f of x. Okay, this is very important because a lot of students, they get confused. So f inverse is not the same as 1 over f of x, but this is 1 over f of x. When the inverse point for all f of x, not just for f. If only for f, it's equal 1 over f. If it's only for f, this is mean the inverse function is not the reciprocal of the function. Okay, now how we can find the inverse? This is very important question. So how we can here finding the inverse of a function. Now we're going to learn how we can find the inverse function. So after like I give you like the basic idea about the inverse function, I said like I cannot find the inverse function until the function should be 1-to-1. So here, and also I give like a graph to how we can find the inverse function by using the graph. Now we're going to learn how we can find any inverse function. So we have some steps. The first step is number one is we have to write y equal f of x. This is the first step. Second step, we have to solve for x in term of y. And the last step, we have to change everything, interchange x and y such that y we have to write it as f inverse of x. So x will be as y, y will be as x here, y will be as x, and y we change it to f of x, to f of inverse of x. Here f inverse of x. So we have to write y equal f of x, solve for x in term of y, interchange y will be as x, and y we change it to f inverse of x. Okay, let me give you example and I will show you how we can use these steps. So here, example, find the inverse for the function f of x equal 3x. Yes, I will go back. Plus minus 2. This is my example. The question is find the inverse of this function. Here you go. You're welcome. So finding the inverse of this function, we have to use this step. The steps are this. First of all, we have to write y equal f of x. So I'm going to do this one by myself. Step number one, we have to change f of x to y equal 3x minus 2. This is the first step. We have to change f of x equal y. Second step, we have to solve for x in term of y. This is mean we have to make x equal something like anything here. We have to solve it. You have to solve for x in term of y. And here is the y, something. Okay, how we can solve this one for x in term of y? What we should do, first of all. Natasha said it's y plus 2 over 3. Can you explain step by step what you did? So he add 2, exactly. We add 2 for both sides. So after we add 2, I will get y equal y plus 2 equal 3x. Now, what's the second step? Then isolated x by dividing by 3, exactly. So we divided 3 for both sides, like this. I will get y plus 2 over 3. This is equal x. I can rewrite this thing as x equal y equal y plus 2 over 3. Now, what is the third step? Interchange y as, we should interchange y as x and y as f of x. So we should to change y as x, and x will be f inverse of x. Here will be f inverse. This is f inverse. This is f inverse. So we should to change x as y. I mean x as f inverse. So the third step here, x will be f inverse, y as x, and y as f inverse. So here will be like, here's some like, hold on 1 second. So here y as x, this is correct, and x as f inverse. Here x, just small modify, y as x and x as f inverse. So this is my f inverse here. Here is my f inverse. So this x would be like f inverse of x, and this y as x. And this is my f inverse of the function. If I want to rewrite this in different way, I can write it as f inverse of x equal x over 3 plus 2 over 3. Any question? Any question for solving this? Okay, I need someone to solve the next example. So the example is, find the inverse for f of x equal x to the power 5 . Here's my function, x to the power 5 minus 3 over 2. Okay, step by step. We'll do the first step. We'll do the first one. Change f of x by y. Replace f of x with y. Okay, this is y equal x to the power 5 minus 3 over 2. Okay. Now, second step, we have to solve it in terms of multiply both sides by 2. Exact. So multiplying this we're going to multiply it by 2. And this is by 2. Then add 3, exactly. So I'm going to get here y times 2 times 2y equal x to the power 5 minus 3, because the 2 times 2, they will cancel out. Then add 3 for both sides. Okay, nice. I added 3 for both sides. I will get 2y plus 3 equal x to the power 5. Now what I should then take the fifth root of both sides. Nice, correct. So take the fifth root. Here is the fifth root, and here is the fifth root. The fifth root with the exponent will cancel out. So I'm going to get x equal the fifth root of 2y plus 3. I can rewrite these things as x equal the fifth root of 2y plus 3. Now, what is the third step, the last step? Interchange x as f inverse of x. So f inverse of x. F inverse of x equal the fifth root of 2x plus 3. Natasha, this is correct. And this is my solution for solving, for finding an inverse function. Any question for this? Okay, I'm going to move to the next slide. We have another example. So the example is if f of x equal 2 minus 3x. The question is find f inverse of 10 minus 10. Again, if the function f of x equal 2 minus 3x, find the f inverse of minus 10. So in this example, they ask about how we can find the inverse. Natasha said 32. We're not going to plug this inside of f function. If we plug this thing here, the minus 10 inside the f function, we're going to get 2 minus 30, and 2 minus 30 is, I mean, like 2 minus 30 will be 32 plus positive. This is correct. But the question asks, find the f inverse of minus 10. So to find this thing, we should to find the inverse function. Yes, Damila, we should to find the inverse function, then we have to plug the minus 10 inside the inverse function. Okay, how we can find the inverse function? So step by step. What is the first step? Y equal, exactly, y equal 2 minus 3x. Then we have to solve it in terms of y. So number 2, we solve for x in terms of y. This is mean we have to subtract, I mean like we have to subtract 2 from both sides. I will get y minus 2 equal minus 3x. Now the second step, we have to divide both sides by what? By minus 3. Yes, dividing both sides by minus 3, this by minus 3, I will get x equal y minus 2 over minus 3. Okay, now we should to change the function. It's the third step. Third step said we have to change x as f inverse and y as x. So here f inverse of x equal x minus 2 over what? Minus 3. Now we can plug the minus 10 inside this function. So f inverse of minus 10, we have to plug the minus 10 inside the function. I'm going to get minus 10 minus 2 is minus 12. Minus 12 over minus 3 is 4. Exactly, minus 10 minus 2 over minus 3. And this is equal minus 12 over minus 3. And the answer is the minus dividing by minus, they cancel out. 12 dividing by 3 will give me 4. So the answer is positive 4. And this is correct, Bilal. This is also correct. So f inverse of minus 10 is 4. Any question for this example? But I use the term x equal y plus b to solve the inverse. How you use it? Can you explain?
Yeah, so let's say like this one we did y equals f of x equals 2 minus 3x. I just did x
Hold on, y
equals
equal what? Y equal what? Minus
2. I'm just repeating the function, but I did x
x equal what?
equals 2 minus 3y.
Equals to minus
3y.
3y.
Yes.
How you use this thing?
I just reversed the that's what I learned back in high school. That's the way I
Okay.
done it.
So you change y to x and
Yes.
x to y. Okay.
Then I did the converse operation of 2, so minus 2 in both sides.
Okay, minus 2 for both sides. You
So
get
it's gonna
what?
be x minus 2 equals negative 3y, and I just divide negative 3 in both sides.
Okay, minus 3 for both sides. I will get x minus 2 over minus 3 equal y.
Yes.
Then that's it, right? This is the function, the
Yeah.
inverse
Then I
function.
plug the negative 10 into and get negative and get 4.
Okay, nice. Yeah, the same. Both of them like close to each other, but not the same exactly. Here, the steps here, we have to change y, the f of x by y. Then we have to solve it for x in term of y. Then we have to change x to f inverse and the y to the x. Both of them, they are correct. So in the exam, if you use this way, will be correct. If you're using my way, like the book mentioned it, also correct. Whatever you want to use, but the important things, the answer must be the same. The answer must be correct. Okay? Very important, the answer must be correct. Okay, the last example about the inverse function. So the example is find the inverse function for my function is f of x equal, find the inverse function for f of x equal this is equal to x plus 3 over x minus 1. The question is find f inverse of x. So who will start doing this one with me? First step, we have to change f of x to y. What I'm going to get, we have to change f of x to y. So y equal what? Same function, 2x plus 3 over x minus 1. Okay, who will do the second step? Solve for x in term of y.
You multiply x minus 1 on both sides.
So yeah, this is correct. We multiply both sides by x minus 1, or we can do the cross multiply. Both of them correct. So actually this is like y over what? Over 1. So we do cross multiply like this. I'm going to get here in the second step y times x minus 1 equal 1 times this will be the same things, 2x plus 3. Now we should what do? Distribute. Okay, so y times x, first one, minus y equal to x plus 3. Now what is the second step? Add y for both sides. Okay, so I'm going to do add y for both sides, add y. This cancel out, I get yx equal 2x plus y minus plus 3. Then subtract 2x. Okay, now nice. So minus 2x for both sides, minus 2x. Yeah, so the goal is to make the x's close to each other in one side and the other things in on the other side. So I'm going to get yx minus 2x equal y plus 3. Okay. Now what I should do, I get here x and here is the other x. What I should do now? I don't know what to do next, but okay. So what about if I take, if I factor here? I take the common factor between the first term, this is the first term, and the second term. What is the common factor here? Yes, it's x, exactly. So x open parentheses y minus 2, correct. And this is equal what? Y plus 3. Then what is the next step? I'm going to looking for x. This is my goal. I need x. Then divide by y minus 2. Correct. So I'm going to divide both sides by y minus 2. Y minus 2, y minus 2. This will cancel out. I will get x equal what? Y plus 3 over y minus 2. Now, what is the third step? So this is the second step is done. I find x equal y plus 3 over y minus 2. The third step is the last step. What is the last step? What's the last step in this here? We have to interchange y as x and x as f inverse of x, right? So this is my x will be like f inverse of x equal x plus 3 over x minus 2. And that's it. We finish solving this example. Okay, any question so far? Yes, this is correct, Natasha. No question, right? So it's clear. Nice. Okay. Now the last thing we have to learn how to graph the inverse of a function. If I have a function f of x, I need to graph the inverse function f inverse of x. Okay, here graphing the inverse of a function. So we should know how we can graph the function, so the inverse function. So first of all, we have to graph the original function f of x. If I have, for example, the question asked me to graph the f inverse of the x, first of all, we have to graph the original function is f of x. Then we have to graph also the line y equal x. Then we have to reflect all points on the all the points of f of x around around the line y equal x. So here, for example, if I have, I can say here to graph a function. If I need to graph a function, I mean to graph the inverse function, to graph of the inverse function, f inverse, f inverse of x is obtained by reflecting the original function, the graph, of f of x, of f on the line, in the line y equal x. So to graph the inverse function f inverse of x is obtained by reflecting the graph of the function f in the y equal x. So suppose I have a graph function like this. If my function look like here is my function. This is my function. I need to graph, this is f of x. This function is f of x. The question is graph the inverse function, f inverse of x. So to do that, we should to graph the line y equal x. This is my mirror, y equal x. Here's my mirror. This always is y equal x. This is y equal x. Then we have to reflect all points around this line. So the reflection of the points, for example, here, this point would be like around here. This point would be like around here. This point would be like here. This point would be like close, be like here, and then be like far, then it will be like close like this. So the original function is the black one. Now the graph of the inverse function should be like this. This is f inverse of x. We have to reflect all points around y equal x. So the distance from here to here is the same as distance from here to here. And the same things here, the distance from here to here is the same as the distance from here to here. The distance here I denoted by this two parallel line, and here is also they are the same. I mean the same is the same distance. Any question for this one? Any question? Okay, let me give you an example for like here's the example. Graph the function f of x equal the square root of x minus 2. Then you have to show to find number one, find the equation of f inverse. B, sketch the graph of f inverse. So the first function here is square root of this function here is the square root of x minus 2. Find the equation of inverse and sketch the graph of the function f inverse. Okay. How we can find the equation of inverse f inverse? Let's doing step by step. Who do the first one? A. So I have f of x equal the square root of x minus 2. How we can so what is the first step?
You do y equals square root of x minus.
Exactly. So we're doing y equal the square root of x minus 2. Now, what is the second step?
You do a square on both sides.
Yes, this is correct. So we're doing square for both sides. So here is the square for both sides. I will get what? Y square equal what?
X minus 2.
X minus 2. Now, we should to solve
Add
it in
2
terms
on
of,
both sides.
yes, add 2 for both sides. I will get x equal y square plus 2. Now the third step. What is the last
You
step?
do inverse of f of x equals
Exactly.
x squared
Okay.
plus 2.
Yes, thank you, Bilal. So first step, we change y instead of x. Then we solve it in terms of y, x in terms of y. Then the last step, we change x to f inverse of x and the y to the x square. Now, sketch the graph of f inverse. So to do the second part, we have to graph the original function f of x equal the square root of x minus 2. Then we have to reflect this function around the line y equal x. So second part, number B, sketch a graph of f inverse. So again, we have to graph, first of all, graph f of x equals square root x minus 2. Okay. So what is the original function before we graph this one? Can you go back a second? Yes, here's. You're welcome. So to graph this function by using the transformation in the previous section, first of all, we have to know what is the original function of x equals the square root of x minus 2. What is the original function? What is O of x? What is the original function here? This is like we're going to graph this one by using the transformation. But before we start for the transformation, we should to know what is the original function because we have to graph it. Then we have to do some steps to get the function f of x equal to the square root of x plus 2 minus 2. So what is O of x, the original function? Do you remember the x squared? The function square root of x. This is my original function of this. So first of all, we have to graph the function O of x equal x squared. This is O of x equal the square root of x. Now, how we can graph the f of x equals square root of x minus 2? How many points we have to move the original function? And to which side we have or which direction we should to move O of x? Any idea? So this is my function. This is my O of x, the original function, square root of x. Natasha said we should to move it to the down 2 units. Okay, look, Natasha, this is my O of x, right? O of x equals square root of x. We have to modify for this function to make it similar to this. What we should to plug here instead of x? Minus 2, or should move plugging x minus 2 like this. We have to plug here x minus 2, not only minus 2. So what I'm going to get, O of what? X minus 2 equal the square root of x minus 2. Look, x minus 2 here, this is the same as this, and this is equal f of x. So this is f equal f of x. This is just a review because we're doing a lot of examples in the previous lecture. So now O of x minus 2 equal f of x. So this is mean the function f of x, this one, equal O, the original function x minus 2. So to graph this function, we have to graph the original one, then we should to do what? Minus 2, this is mean what? We have to move 2 units to where? Up or down or left or right? Shifted 2 units to the right. This is correct. Because the 2 is inside the parentheses, this is mean we have to shift the original function, this one, 2 units to the right. So here is 2 units to the right. This is the graph. Here is 1, here is 2. So the graph of the function should be here. This is f of x equal the square root of x minus 2. Now we have to graph the inverse function. I'm going to erase this function, the blue one, because I need some space. Now we have to make the line for reflection. This is my reflection line to find the graph of the inverse. This is y equal x. Y equal x. So we have to reflect all points in the red around y equal x. Okay. So this point, after we reflect it around the y equal x, this is my mirror. It must be here. This is 2. And all this point should be after we reflect it like this. So this is f inverse of x. This is the inverse function, the graph of the inverse function. Any question? So this is the graph of this function, x squared plus 2. But here we have some important thing. Here we have to define the domain. Here x must be greater than 0. Here is the domain is x greater than 0. So as we see here, the domain starting from the 0 goes to infinity. Any question for this example? Okay, so now this so by this example we finish the section 2.8, the one-to-one and inverse function. Now let's go to the 3.1, the quadratic functions. Quadratic functions. So I'm going to give brief like a short review for the quadratic functions. So first of all, before I start this section, I need someone to define what is the mean of a quadratic function. What is the mean of a quadratic function?
To answer your question, a quadratic function is different to a linear function in the sense that quadratic exponentially gets greater over time, whereas linear has like a constant rate of change.
Okay, this is correct. But can you like explain it more? Like, how is the formula for the quadratic function? I mean, also, what is the highest exponent for the quadratic function? If I wanna like write or like define it, like what is the highest exponent for the variable for this quadratic function? Yes, Amar, he said is 2. This is correct. And he defined 2 is x squared plus bx plus c. This is correct. So the quadratic function is a function of this form: x squared ax squared plus bx plus c. So I can said here the quadratic function is a function this is a function of the form f of x equal a times x squared plus b times x plus c. So this is the quadratic function. Anything of this form is called a quadratic. Here we don't have to forget the square. So here we have ax squared plus bx plus c. Or I can define it in different way. It's a polynomial function of degree 2. So the polynomial function, let me define the polynomial function. The polynomial function is polynomial. So let me remind you what is the meaning of polynomial function. Is a function of the form b of x to raise to the with degree n is a n x to the power n plus a n minus 1 x to the power n minus 1 plus dot 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 plus a1 x to the power 1 plus a0. This is the polynomial function of degree n. But if the degree is 2, it's going to be like a quadratic function. If the degree is 2, then I will get a quadratic function. Quadratic function. Okay. If the degree of this is 2, then I'm going to get a quadratic function. First of all, in this section, we're going to learn how we can graph the quadratic function. But to graph the quadratic function, we need a very important thing is to change or to rewrite the quadratic function on the standard form. Maybe you hear about this in high school. Let me review what I mean of the standard form. So the quadratic function, actually, the quadratic function ax to the power 2 plus bx plus c, I can write this one in the standard form like this. I'm going to change it can be written of the form f of x. This is here f of x equal ax squared plus bx plus c. I can rewrite this one as f of x equal a times x minus h plus k. So I can rewrite the quadratic function in the standard form. This is my quadratic function, and this is also my quadratic function in the standard form. So this is my standard form here. Standard form. This is my standard form. Now we should to know how we can graph any quadratic function by using this standard form. If this a here, first of all, the vertex for the quadratic function should be h comma k, the order pair of h comma k. So here I can set like to graph the function to graph to graph the quadratic function is look like a parabola with vertex is h and k, h comma k. What is the meaning of h? The h I can find it from the standard form. If you go back to the standard form, this is my standard formula. I change this, the quadratic function, to the standard form. So any quadratic function, the graph is look like a parabola, such that the vertex will be like h, this point, and k. H and k. So this is mean this point and this point is very important points. H and k, they are the vertex of the parabola. And the parabola, you have to know if a is greater than 0. So if this a, I mean this a, if this a is greater than 0, to know if a is greater than 0, I mean like greater than 0 is positive number. If this a is a positive number, the parabola opens upward and the function has minimum value is f of h equal k. This is very important things. If this a, this is a positive number, then the parabola should be open upward and it has a minimum value is f of h equal k. But if this parabola is open downward, I mean like if a is if this a, I mean like if this a is less than 0, here greater than 0, here is less than 0. The parabola opens downward to the down. And the function has maximum value is f of h equal k. So again, this is the standard form. This is very important form. This is will help me to graph any quadratic function. Okay. So first of all, we should to know this two important. If this A is open parabola, if it's a parabola, if this A is greater than 0, I mean like positive number, any number greater than 0, like 1, 2, 3, 4, any number, or 1/2 or 3/5, then the parabola must be open upward with the minimum value is f of h equal k. But if this A is less than 0, like negative number, so the parabola must be open downward, and the function will has a maximum value. The maximum value is f of h equal k. So I'm going to graph like two parabola. Here is the first graph, and this is my second graph. So for the first one, if my A is positive, so the graph will be like this. This is the parabola, open upward. If the parabola, for example, it's not exactly in the standard form, I can like move it like this. So it can be like something like this. This is my x-axis. This is my y-axis. Here is the x-axis, and this is y-axis. This point is h, and this point is k. So here f of x equal ax, ax minus h squared plus what, k, such that here a is greater than 0, positive. But for the second one, suppose my parabola look like this. And this is my vertex. So this is again h, and this is k. Here is f of x equal a times x minus h squared plus k. Here the a is negative number. Any questions so far up to here? For the standard form is not supposed to have exponent on x minus h squared. Yes. Oh, yes. Sorry for that. This is correct. Thank you, Anta. Here, this is square. I forgot the square. And here we have square. I put the square already. I have put the square here. But here I forgot the square. So here f of x equal a times x minus h squared plus k. And here f of x equal a times x minus h squared plus k, such that here a is positive and this is a negative. Here, don't forget the square. Here is equal. This is equal sign. Okay, any questions so far about this thing here? Again, let me explain again. The quadratic function is a function of the form f of x equal ax squared plus bx plus c. The important things we have to know to graph the quadratic function, we have to change it to this one, to the standard form. Standard form said if this a is positive, we can find, so the graph of the quadratic function is a parabola. If this a is a positive number, so the parabola should open upward and it has a minimum value is f of h equal k. If this a is negative, this is mean the parabola opens downward and the function has a maximum value is f of h equal k. And you should to know that the graph has it's a parabola with the vertex h and k. The h comma k, they are the vertex of the parabola function. Any question? Okay, if there is no question, we have example here, but we're going to stop up to here, and I'm going to do the example next time because the exam needing more times. Okay, have a good day. I will see you next week.
Have a good day, Professor.
Have a good day. Bye, have a good day.